You know, we check it constantly. We're always racing against it, feeling every single moment tick by. But have you ever stopped to wonder, how did we get so darn good at measuring something as mysterious as time itself?
I mean, think about it. If you've ever watched an Olympic sprint, you have literally seen a race decided by less than the blink of an eye. We can nail timings down to the thousandth of a second, which, it kind of makes you wonder, right? How on earth did we go from just watching the sun move across the sky to capturing moments with that kind of crazy, astonishing accuracy? Well, that is exactly the journey we're going to take today. So, let's start at the very beginning, in the ancient world. See, long before we had any gears or batteries, the first clocks weren't really built at all. They were just observed. For the longest time, people just used nature's clock. The sun rising and setting, that's your day. The moon doing its thing, that's your month. The seasons changing, hey, a year just went by. And that was great for the big picture stuff, but what about the smaller chunks of time? What about the hours inside a single day? Well, this is where humans got super creative. They figured out how to use the sun's shadow with these things called sundials. They built water clocks, or clepsydras, that measured time by a steady drip, drip, drip of water. And of course, the classic hourglass with its constant flow of sand. Some people even used marked candles to literally watch the hours burn away. And don't think these were just simple little gadgets. Some were incredibly sophisticated. I mean, just look at the Samrat Yantra in India. It's this gigantic stone sundial. We're talking 27 meters high, and its shadow moves so precisely it can track time down to 2-second intervals. That's just amazing ingenuity. But all of these clocks had a big flaw, right? What happens when it's cloudy or when the sun goes down? What do you do when the sand or water runs out? Yeah, for the next big leap forward, we needed something totally new. A mechanism that was perfectly, reliably regular and didn't depend on the sun or a bucket of water. And the inspiration? It came from a pretty surprising place, a swinging lamp. And believe me, this was about to change everything. So the legend goes, sometime back in the 16th century, the famous scientist Galileo Galilei is just sitting in a church, probably a little bored, and he starts watching this lamp swinging back and forth from the ceiling. And just out of curiosity, he starts timing the swings, using his own pulse. And that's when he notices something incredible. Every single swing, big or small, took the exact same amount of time to complete. This was the huge breakthrough. What Galileo figured out is that the time it takes for a pendulum to swing, its period, it only depends on one thing: how long the string is. It doesn't matter how heavy the weight at the end is, or even how far you pull it back. And just like that, boom, humanity had found it: a perfectly regular, predictable mechanical motion. This was the secret ingredient for a truly accurate clock. So with that key discovery in hand, a Dutch scientist, Christian Huygens, took Galileo's idea and ran with it. He figured out how to harness that perfect swing, and in 1656, he built the world's very first pendulum clock. And yeah, it changed timekeeping forever. And just how good was it? Well, his first clock was only off by about 10 seconds a day. Now, you have to remember, older clocks could lose 15 minutes a day, or even more. So going from minutes to seconds, that was a massive, massive leap. A total revolution in precision. But as amazing as that was, it was really just the beginning of the story. Fast forward to today, and you'll find that our most advanced clocks, atomic clocks, actually use the very same principle as the pendulum. It's all about finding something that repeats at a perfectly constant rate. It's just that instead of a swinging weight, they use the unbelievably fast and ridiculously stable vibrations of individual atoms. And the accuracy? I mean, it is just mind-blowing. Today's atomic clocks are so precise, they might lose just 1 single second over millions of years. Just let that sink in for a moment. We went from a clock losing 10 seconds a day, which was revolutionary, to a clock that loses 1 second over a period that's longer than human history. That jump in accuracy is it's almost impossible to really comprehend. Okay, so we totally mastered telling time, the when, but all that amazing precision unlocked a whole new door, figuring out how fast things are going. See, once you can chop time into tiny, accurate little slices, you can start to measure speed and motion with that same incredible accuracy. So let's start with the easy one, uniform motion. The best way to think about it is like a train on a perfectly straight track, out in the middle of nowhere. No stops, no hills, it's just cruising along. It covers the exact same amount of ground in every single chunk of time.
So check out the data for train X. In that first 10 minutes, it goes 20 kilometers. The next 10 minutes, 20 kilometers again. And the next, you guessed it, 20 kilometers. It's like clockwork, totally constant, totally predictable. That, right there, is uniform motion.
But, real life is almost never that smooth. Most movement out there is what we call non-uniform motion. It's messy. It's you driving a car in city traffic, right? You're constantly hitting the gas, then the brakes, speeding up, slowing down.
Okay, now let's look at train Y. It starts out pretty fast, covering 20 kilometers in the first 10 minutes. But then it slows down, only covers 15. Stays slow for a bit, then speeds way up and covers 25 kilometers in that last interval. See? The time chunks are the same, 10 minutes each, but the distance it travels keeps changing. That's non-uniform motion. That's what most travel actually looks like.
All right, so this brings us right back to the beginning. We've got all this incredible precision, but why does it actually matter? What's the point of all this in our everyday lives?
Well, the truth is, it's absolutely everywhere. It's in sports, where races are won or lost by 1,000th of a second. It's in medicine. Think about an ECG machine tracking the tiny millisecond-long electrical signals of your heart. It's in every piece of tech you own. Your computer processes information in microseconds. That's millionths of a second. This hyper-precise timekeeping is literally the invisible engine that makes our modern world run. So think about the journey we just took. We went from watching shadows move on the ground all the way to harnessing the almost perfect rhythm of a tiny atom. We can now measure time with a level of precision that it's just almost beyond our ability to grasp. And yet, after all of that, it leads us to one last really deep question. With all our incredible ability to measure it, what is time anyway?